Hi there. So we are continuing in section 4.5 to solve triangles, meaning solving for the unknown sides and angles of a triangle. We are using the law of cosines to solve a triangle when we are given a side angle side or all three sides of the triangle. And we're also going to be finding the area of triangles. Now, your textbook gives formulas for each when you're given a triangle with side angle side, or if you're given a triangle side side side. I'm going to show you how to do this without having to remember this formula, as you guys already know area equals to 1/2 base times height. So I prefer to just figure out what the height is of the triangle. Sometimes that's a little more work than using those formulas, but we'll talk about that in a few minutes. Okay, so we are still solving triangles. We're solving SAS and SSS case 3, and case 4 using law of cosines. Now, this looks like three different formulas, or at first it looks like three different formulas, and your textbook writes law of cosines as three different formulas, but it's not. It's really just the side opposite the angle that cosine is being evaluated with squared equals to the sum of the other two sides squared minus 2 times each of the other sides times cosine of the angle that is opposite to the side that's on the other side of the equation, right? So you just need to really memorize kind of the order. A, B, and C are arbitrary based off whatever information you're given. So it's not really three formulas that you have to memorize. Now, you're going to see as we're working through these examples that sometimes you're like, well, wait, I could switch over to law of sines. And actually, your textbook does do this in the way she works out the examples. But I'm going to suggest or highly recommend that if you're able to use law of cosines, you just stay in law of cosines. And that's because if you remember, in law of sines, if you're solving for an angle, you have to use inverse sine. And inverse sine of a positive ratio is going to always give you an angle from quadrant 1. Or actually, even if a negative ratio will then give you, it'll actually give you a negative angle. Whereas inverse cosine, which is what you would use in law of cosines, is going to give you an angle from quadrant 1 or quadrant 2. So it'll give you an acute angle or an obtuse angle. If you switch to law of sines before you have solved for the largest angle of the triangle, you could accidentally run into the ambiguous case as well and solve for the wrong angle, not the actual angle of the triangle. For the SAS case or the SSS case, so case 3 and case 4, there's exactly one triangle that could exist with the given information. So we want to make sure that you don't accidentally run into an ambiguous case when it's not actually ambiguous. Okay, so you'll see what I mean here. In this example, we're given side angle side, and if with the given information you don't recognize that side angle side, what I suggest doing is you could just sketch a triangle, go, okay, well, this is alpha, beta, gamma, A, B, C. You're given 4.2, 1.8, and 35 degrees. So I see, oh, okay, I'm given side angle side. That means law of cosines. If I wanted to try to solve for one of the other sides or angles here, there's no way that I could use law of sines to do that. So that's also just kind of a red flag that, hey, I need to use law of cosines. And the only thing that I can solve for right now is going to be side A. So using law of cosines, I would write a squared equals to the rest of law of cosines. However, I'm going to skip that step since I'm just trying to solve for A. I'm going to write law of cosines as A equals to the square root of b squared plus c squared minus 2 times b times c times cosine of 35 degrees. Type that into my calculator. Make sure you are in degree mode. So I get 2.9145 for side A. Now I have all three sides. Well, it would appear that you could switch to law of sines right now to solve for another angle, either angle beta or angle gamma. However, we do not know what the largest angle is yet. Because we are given angle alpha. However, the longest side is B. So that means beta will be the largest angle, and beta could be an obtuse angle. Inverse sine is not going to give me an angle from quadrant 2. So I need to use law of cosines to solve for angle beta. Okay, so using law of cosines, we'll have 4.2 squared equals to a squared plus c squared minus 2 times a times c times cosine of beta. Okay, so now I need to isolate cosine of beta. So I'm going to subtract a squared and c squared and then divide by this product here. So we'll end up with cosine of beta is equal to 4.2 squared minus 2.9145 squared minus 1.8 squared, all divided by negative 2 times 2.9145 times 1.8. So that's equal to the cosine of beta. So we need to take the inverse cosine to find what beta actually is. So I'm going to do beta equals, I'm going to switch this around, inverse cosine of this ratio. Instead of writing it all again, I'm going to see if I can copy and paste. There we go. Okay, now I need to type that all into my calculator. Make sure you are using parentheses around the numerator and the denominator. I get 124.2541 degrees. And I'm glad that I did not switch to law of sines because inverse sine, let's think about it, all students, okay, so inverse sine would have actually given me a negative angle. And we could have figured out what the angle should have been in quadrant 2. But it's just a lot easier to use inverse cosine. So like I said, when you can use law of cosines, just use law of cosines. Okay, so now we have all three sides. We have alpha and beta, so we can find gamma using the fact that the angles should sum to 180 degrees. Will be an approximation. And I I get 20.7459 degrees. Okay, I'm going to ask you guys on your assessments to summarize all of the angles and sides. For now, for the sake of time, I'm just going to highlight what our solutions are. Okay. So next example is another case of SAS. We have to solve for side C first. So again, instead of writing C squared, I'm going to write C equals to the square root 5 squared plus 6 squared minus 2 times 5 times 6 times cosine of 170 degrees. And I get C is approximately 10.9585. Okay, so we can just go in alphabetical order. In this case, because we're given that gamma is an obtuse angle, we know the largest angle of the triangle. So you actually here could switch to law of sines and it would be safe. But again, I like to just stay in law of cosines. So now I'm going to solve for alpha. I'll just go in alphabetical order. So using law of cosines, okay, so alpha will be equal to the inverse cosine, and I want you to make sure you are writing down this step at least, the step where you're showing me what you're actually putting into your calculator. Oh, I'm missing 6 squared. Okay, so I get alpha is approximately 5.4549 degrees. Okay, we have all three sides. We have two angles. Now we can solve for beta, our remaining angle, using the fact the angle should sum to 180 degrees. Oops, 5.451 degrees. Okay. All right, so the last case, side, side, side case. If we're using law of cosines and we're just using law of cosines, we can solve for any of the angles first. Like we can go in alphabetical order. That sometimes helps keep your work organized. If you wanted to switch to law of sines, then you would want to solve for your largest angle first. You would want to solve for angle gamma. So you could do 8 squared equals to 5 squared plus 7 squared minus 2 times 5 times 7 times the cosine of beta So we get that beta is 81.7868 degrees. Okay, and then we need to solve for another angle. You could now switch to law of sines if you wanted to, because you've solved for the largest angle. But I'm going to stay in law of cosines. I'm going to just solve for angle alpha next. So for alpha, I had a calculator error. It's 7. In just 1 second. So for alpha, I end up with 38.2132 degrees. Sorry, I had a little technical difficulty. Oh, here's why. I had 5 in the denominator, and it should be 7 times 8. Okay. So now we have beta, alpha, and we can solve for gamma. And we get 60 degrees. Exactly. And I believe that's what we got when we were using inverse cosine as well. So when we used law of sines to solve for gamma yesterday in class. Okay, so those are the 3 angles. I'm going to skip the next example. I'm happy to make another video or go over it with you if you'd like. Just shoot me an email or see me in class. But I'm going to switch to area. So you guys know that the area of a triangle is equal to 1/2 base times height. You've known that for a very, very long time now. So just drawing, this is not a triangle that's to scale or anything. So if this is alpha, beta, gamma, A, B, C, and gamma is 86 degrees. So I'm going to actually rotate this triangle so that my base is 7 feet. So A. So that would make this gamma, alpha, beta. Okay, all I did was rotate the triangle. So we are missing the height of the triangle. So the height would be a perpendicular, where you can construct a right triangle. And you could solve for the height of the triangle by saying, okay, well, sine of 86 degrees is equal to h over 9.3. So h equals to 9.3 times sine of 86 degrees. Okay, therefore, the area of the triangle would be equal to 1/2 times the base, which we're using is 7, times 9.3 times sine of 86 degrees. Now this is actually this is the formula for SAS that Cynthia Young gives. So you can you don't need to memorize the formula. You can, but you don't have to. My computer is going to die in a sec. That's okay. Let's see if we can make it. So A equals approximately 32.4707. It'll be feet squared. Okay, we're finding the triangle side, side, side. We're given all 3 sides of the triangle. You could use what we call Heron's formula, which is area is equal to the square root of S times S minus A times S minus B times S minus C, where S equals to the half perimeter of the triangle. But that's a formula you can memorize. But I'm going to send you how to program this formula into your calculator. So if you want to be able to use it on your SAT Choose or whatnot, if that comes up, then you just have it. You don't need to have the formula memorized or anything. The way that I would do this is, okay, if we have a triangle, alpha, beta, gamma, A is equal to 5, B is 6, C is 9. Okay, if we can drop it perpendicular, we then create 2 right triangles where we would want to solve for beta or for alpha. Now, I'm going to solve for beta. So I can use Law of Cosines to solve for beta. So 6 squared equals to 5 squared plus 9 squared minus 2 times 5 times 9 times cosine beta. Okay. So we can solve for beta, and then you could solve for the height of the triangle. I'm so sorry, my computer is about to die, so I don't want to lose this video. But you could solve for beta, and then you could use area equals to 1/2 base times height once you have h is equal to, it would be 5 times sine of beta. Okay.